Hey guys, so this is the second part of your notes from yesterday. So the first thing we always want to do is to graph the parent function, which is this function right here. So I'm going to pause the video and type it into my calculator real quick so I can put the table on here for you guys. So when I typed in 2 to the x, this is the table I got. So now, check to make sure your points are the same as mine. And we are going to graph these. And so I'm going to use gray for the parent function, and I'm going to use red for the second function. So go ahead and pause this video, graph your points, and when you're done, unpause the video. So these are the points you should have graphed. Then remember, you have to connect the dots. So when you connect the dots, this is the graph you should have. And remember, your asymptote for this is going to be 0. So remember, your asymptote's at 0 because you can't see that, right here, there's no number to the right side. It's a big plus 0. So I am going to draw that in a highlighter so you can see it a little bit better, hopefully. So there is your asymptote of 0. That's this guy right here. And then your next function actually also has that plus 0 on the ends, so your asymptote's not changing at all, so it's going to stay the same. So we're just going to use that same dashed yellow line. And remember, when you're drawing it, it has to be dashed. So the next thing we're going to do is I'm going to plug the second function in, this f of x equals -2 raised to the x, into the calculator so I can draw the table for that one. So I'm going to pause this and make the table. You do the same. So when you type this into your calculator, you should have got this red table right here. And I made sure to use, since I did -2 to 3 on the x's for my gray table, my parent function, I did the same thing for the red one. So I can kind of compare them better. So -2 to 3. So I'm going to go ahead and pause this, and I'm going to graph the points again. So when you graph your red table, or whatever color your table is, you should see the same points I have. So I'm going to connect my dots. And now I have my second graph. So the only difference between the parent function and the red graph, the gray and the red graph, they all have almost the same points, but all the gray points up here turned negative. So this one was 2, 4, so then the red was 2, -4. So over on the right side, you're going to write multiply by a negative and that ends up being a reflection across the x-axis. Reflection across the x-axis. So when there's a negative out front, which is this guy right here, it's a reflection across the x-axis. It makes it go from up top, above the asymptote, to below the asymptote. Okay, let's go to the next one. So again, I'm going to graph 2 to the x. I already have the table, so I'm going to use the same table right here, down here. So I'm not going to rewrite it. I'm just going to regraph the parent function, which is this guy. So pause and graph it as well. Okay, so your parent graph should look the same as above. Again, that's called the parent function. Next, we're going to type in the second one. I'm going to make it red again, into the calculator. Remember, when you type it in, as a refresher, table, and then if there's anything in there, hit clear. So it'd be a 3 parenthesis 2 close parenthesis, and then your caret button right here, caret, and then X is below, and then enter. Make sure your start is at 0, and 0, enter, 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 enter. So there's my table. So I'm going to go ahead and pause this, write down my table, and you do the same. So the table you should have gotten is this same table I have in red. So I made sure though, because the table gave me 3/4 and 3/2, I changed those to decimal places so I could graph them easier. So go ahead and pause this and graph the points. You can. Obviously, 12 and 24 are off the graph, but do the best you can graphing them. So pause and graph. Okay, so these are the points you should have graphed. I know 212 right here is off the graph, but I kind of plotted it up top because it's pretty close. 10, 11, 12. I just kind of guesstimated. So connect your dots as best you can. So these are the two graphs. So looking at the gray one, which is like the bottom one, versus the red one, if we compare points, so if we look right here, so 0 was 1, now 0 is 3. This was a 2, now it's a 6. This was a, what's that one? A 4, now it's a 12. So every time each point is going up vertically, and so we call that a vertical stretch when the number gets bigger. So in this case, all numbers were multiplied by 3, and that 3 in our equation was right there out front. So on the right side, we're going to say multiplied by a number greater than 1, because 3 is a big number, it's greater than 1. I'll put a nice little pretty box around it. And then what happened? It was a vertically stretched by a factor of blank. So in this case, our factor was a 3. If there was a 10 out front, you'd put stretched by a factor of 10. Okay, our last function. Go ahead and graph the parent function and also make the table for B. I'm going to pause. So go ahead and check your table. I'm going to pause the video and I'm going to graph the points. So when you graph these points, your red line, or my red line, is now below the gray line. And if we compare to our original points, so in this case, this was a 1, now it's a half. So I only graphed these points right here because the others were itsy bitsy. So then it was, the next point was up at a 2, now it's at a 1. Then it was at a 4, now it's at a 2. It was at an 8, now it's at a 4. So every single time, because of this 1/2 in the front, all of your original values got cut in half. And so we call that, since we multiplied by a fraction, we call that a shrink. So over here, you're going to write multiplied by a number less than 1. So multiplied by a number less than 1. And when you do that, it's vertically shrink by a factor of blank. That's what we're writing below. Vertically shrink by a factor of blank. So in this case, it was vertically shrunk by a factor of 1/2. If it was a 1/10 in the front, it'd be vertically shrunk or shrink by a factor of 1/10. Just whatever number, whatever fraction is out front. So this completes your notes. Have a great day, guys.